from Jerry Martau. And then today I am very excited because there is this adjustment in the order. So I have a chance to kick things off, be the first to share. The topic we are sharing is what we have done at Jerry, building a ClickHouse architecture based on FS. And then I will proceed with my presentation on this topic, providing detailed insights and examples. You all may not be very familiar with our company. The name of our company is Jerry. Just wanted to clarify that. So we are a kind of car ownership app that manages your ownership of a car. And what we mainly do is to utilize AI and automation technology simplify your comparison and purchase of automobile insurance and vehicle loans. We are presently the top-ranked application in this industry in the United States, and by the year 2023, we are positioned as the 123rd company in the YC organization. Allow me to introduce this why. The main key point is that our company is actively seeking to recruit remote engineers in China at the moment. Engineers working remotely from home. So if you have, if you are looking for a new opportunity or you want to try out the remote working lifestyle, you can. Please add me on WeChat if you enter Jerry through my referral, although you will not get a substantial amount. I will receive a sum of money as a reward. So I am going to leave this page open for a little while longer so that you have enough time to scan and add my WeChat contact information. My name is Ma Tao, and I am the head of the data engineering department at Jerry. So the topic we are discussing today is, if some of you are familiar with Clicks and Joseph Fiss, it will be easy to understand the approach we took and how we achieved it in our project. So I desire to maximize its usefulness for all. I opine that the methodology we employ presently could be highly meaningful for startups or small businesses situated within large companies and organizations. Therefore, we included additional sections regarding Jerry's complete data architecture and provided more information on our approach to this design. Firstly, the central aspect of our data architecture is the portion that caters to the queries of all users, correct? Jerry is constructed on a primary ClickHouse architecture with Snowflake serving as a secondary element. The purpose of having this slide is to be prepared in case you may have questions at a later time. Upon reviewing it, you may ponder, what if you are unable to calculate the clicks? In those 1% or 5% of instances where ClickHouse is unable to calculate, we will transfer it to Snowflake for processing. There is a high probability that we have a way to smoothly exchange data between ClickHouse and Snowflake, and we predominantly utilize ClickHouse for approximately 90% to 99% of all the scenarios we can think of. Furthermore, in addition to Chris, we have developed a master-slave architecture, which is the topic that we are going to discuss in detail during our conversation today. You may not be acquainted with the Clicks-bearing architecture, as it is not currently present in the Clicks community. However, we have constructed such an architecture based on the FS file system technology. In terms of usage, there's no difference compared to the Axis we usually understand. All data updates occur on the master instance, and the slave instance provides query capabilities. This is the way we utilize it in real-world scenarios, employing this particular method, primary dish. So in order to handle all write operations, including data synchronization, ETL and so on, we utilize multiple instances to cater to other startups that are running their own startups. It was a very natural choice for us to begin with Redshift, so our approach may be considered quite typical. We employ Redshift to fulfill some of our analytical query requirements and address the specific needs of our data analysis. In the early days, later, as our data volume grew, we faced significant performance and cost issues. For example, generating important reports like funnel and A/B test reports would sometimes take up to tens of minutes, resulting in considerable delays. These challenges had a major impact on our operations and necessitated immediate action to improve efficiency and reduce expenses. In a cost-effective cluster where we run a lot, it's reasonable from a query perspective. However, in terms of our data scale, it takes a long time to run on a reasonably sized Redshift cluster. So as a result, our data service at that time was in a very unreliable state. So in order to address these issues, we made the decision to find a new solution that would be more reliable and efficient for our needs. This new option is centered around being considerably faster and considerably more cost-effective. Moreover, we want to make it explicitly clear that we fully acknowledge the possibility of not being able to offer real-time updates and deletion operations for these features. Regarding myself, I'd like to mention that we made this English PPT as per the request of FS. I hope it didn't cause any inconvenience to anyone. That's it. So after enumerating these conditions, I believe it should be approximately 3 or 4 years ago, everyone ought to possess a very clear comprehension in their minds that if in this data field, if you are fairly acquainted, a clear term that emerges is ClickHouse. So we made the decision to switch to ClickHouse and embarked on some data warehouse design. This was necessary because our previous setup on Redshift had a storage design issue that we needed to address. Therefore, on this new platform, we also introduced a new storage design in order to overcome the challenges we had encountered with our setup on Redshift in the past. And the final result is that the loading time of these important reports has been reduced from several tens of minutes to several seconds initially. A period of time is usually around 1 second. We have a 1 second character, meaning that the loading time for important reports cannot exceed 1 second, which has been maintained for quite a while. And then secondly, after this transition, our overall ownership costs have decreased to a quarter of what they were before, or even less. And then our entire team, including the data team and other teams, are also very happy because it increases productivity as it allows for faster iterations, meaning it can create those intuitive. This platform, SQL, is what can ensure smooth execution, correct? Therefore, for Jerry, this represents a significant achievement. Well, at that time when we were working on this, you can imagine in a startup company, it's very natural to deploy a single machine technology cause. However, at that time, we also considered, that is to say, how long did we want to stick with our single machine ClickHouse? So it is not just about deploying it as a standalone today, but rather about considering it as well and taking it into account. Is it the solution we desire in the upcoming years? The ultimate conclusion is that we aim to uphold this standalone status for an extended period of time. The first consideration is about equality. That is to say, under the same computing resources, it may still be more efficient because it doesn't have the overhead of that cluster. So it can rely on being official. That is, you don't have to, you can stick to single machine until you know that you can't work on a single machine, right? So the second one, perhaps the most important reason, is that this single machine deployment for us the maintenance cost is the lowest. The maintenance cost comprises not just the cost of maintaining that cluster, but also the cost of maintaining data shedding on the application and the costs exposed to the application layer. The cluster, this thing, is because we examined some of the largest clusters at the time, single servers, which were part of the analysis. It's possible that now it could be even bigger than this, because I recently checked. Our individual machine can have up to 24 TB of memory and 488 CPUs, which is actually more than many. What can be said is that the cluster needs to be large, including its disk bandwidth, which may far exceed the capacity we had planned at that time. So for our team, clickouts are a beneficial strategy that we can adhere to in the foreseeable future, but it does have its own set of challenges, which the chief can share with friends. The first one, when he experiences hardware issues, his period of downtime could potentially be very lengthy. At the very least, it will be, right? Secondly, the process of collecting migration and collecting backups is a significant issue. Up to this point, it has not been easy for us to come up with a good data backup and migration plan on ClickHouse. Not only us, but also ClickHouse, the community. So after we deployed this thing, we did encounter a lot of issues, The first one is that we need to regularly maintain the expansion of its storage because of the data that accumulates over time and requires additional space for storage capacity. The volume is experiencing rapid growth, so you need to ensure a reasonable disk utilization rate. You cannot allow it to be too low, as it will soon reach a certain threshold. Therefore, you must resize it, which requires some effort each time. The second thing is we came across this thing called, during our encounter with it, we realized its significance. The hardware issue mentioned above resulted in other subsequent problems. Well, we are all aware that it is highly aggressive in terms of resource utilization, so it will write to that disk very aggressively, causing quite frequent occurrences, which can lead to further complications and hinder overall system performance. On the hardware side of things, so the first time we encountered this issue, the downtime was approximately 12 hours, meaning after it broke down, I had to move the phone to another location, then restore it, and at the same time catch up on the data during this downtime, which took about 12 hours. This is very, very frightening for a company. Of course, there is also the risk of losing some data. Certainly, I imply, ClickHouse is commonly regarded as this type of data warehouse, generally perceived as a replica of certain data sources. But the issue is, this can be rather problematic for you because you must guarantee that when you query, this data is comprehensive, correct? In a way, comprehensive. In a way, when we work on this, we need to be prepared for situations of hardware failures. So when you do data backup, recovery, and migration, it's all very, very challenging. So naturally, we just think of one thing, which is the importance of thorough planning and contingency measures. The concept is to execute it on storage that is shared. This operation of running on the file system, in fact, is a method that I paid attention to a long time ago. It is not difficult to think of because when I was making this PowerPoint presentation, I searched and found many articles like this. The first link I found is just one example of the valuable resources I came across during my research. An article discussing Ali, potentially a user who utilized Aliyun's object storage service, then implemented it in their own data center using ClickHouse for analysis, and ultimately migrated to the FS solution for data management. The link provided below directs to an official research paper on FS, which appears to have been authored by Professor Gao Changjian providing in-depth insights into the technology and its applications. So what is the deal? Running ClickHouse on FS is a very straightforward approach. So at that time, we conducted some tests and then performed this task. The criteria I selected for this test are similar to the results we obtained, namely its query performance, its read performance under caching conditions, and other relevant factors. Based on these findings, we can confidently conclude that utilizing ClickHouse on FS is a viable option for optimizing query and read performance in our system. The performance of the local hard disk, it's about the same, no significant differences. Then the performance of writing is approximately 10% to 50%, which is indeed a significant decrease, but it is acceptable for us considering the circumstances. Just to confirm, okay? So we established this thing. Obviously, both FS and ClickHouse are exceptional products. So regarding this setup, I don't really have much to mention. Just set it up. The process of setting it up is similar to what we do, and it can incur costs for data usage, which is something to consider. The directory, you install it into the file system and then run ClickHouse on top of it. And there are some parameters here, maybe one that most people would want to adjust, which is the file system mounted on top. This write back should refer to supporting a step of writing. That is to say, it will not, I won't block you on this issue. My understanding may not be very accurate, maybe later. The colleagues from FS will provide a more precise explanation. The second part is about the cache. Well, it is these, the cache of data files and their original information entries. The third one is, well, when we run on FS, there are some input-output I/O operations, and the system calls for I/O operations may take longer than running on a local disk, and during this process, it may be interrupted. This interruption, can you please provide more context or details about the interruption? It is possible that it may cause the application to crash. As a result, there will be a mounting parameter available to adjust its behavior accordingly. We made a few minor adjustments, and the most crucial aspect of the optimization is that we performed this monitoring of cache hit rate on the monitoring interface of FS. We utilized Shine. The commercial version is specifically designed for FS and provides enhanced functionality. So our objective is to enhance the cache hit rate to a level of more than 90%. If it is not sufficient, we have the option to include additional hard drives, correct? So what is currently happening? After the migration to this ClickHouse on file system, FS solution, it has successfully solved many of our problems. The first one is that it has significantly reduced a lot of them. Maintenance costs. One thing is that we don't have to be forced to frequently expand the hard drive. This expansion of the hard drive has become a need for me to monitor its cache hit rate, so it also becomes less urgent, meaning sometimes the first point may not be that significant. The second thing is when a hardware failure occurs, there is no need for data migration. The third thing is that we can utilize the snapshot feature of FS for data backup and recovery purposes. This is probably still quite an attractive feature in the present day, as I am discussing it today. So, if I observe that ClickHouse appears like this, I will capture a snapshot of it, and then after a certain period of time, I am able to retrieve the data using the snapshot feature of FS for data backup and recovery. Running on this data set, what I see is the current state. So at the file system level, it has addressed some integrity issues that we might have had to deal with at the application level before. Actually, my impression is that we wanted to change it to this command, changing it to clone. Did that happen? Well, we can discuss it later. And the second benefit is that our downtime has been greatly reduced, because the main reason is that we no longer need to migrate data. So if we react quickly, or if the automation system works well, after a failure, I can just mount this directory on another machine and bring it up. So the main time is the ClickHouse startup time. Okay, which will take a couple of minutes. The third one, so after we obtain these benefits, this particular thing that we are referring to, the missile performance is, the query performance hasn't changed at all. No one in our entire company noticed that this was done. So this migration serves as evidence that its performance hasn't changed much. Another important point to note is that after this migration, our costs have decreased significantly, because we have replaced the expensive cloud storage with this much more affordable object storage. This transition has proven to be a cost-effective solution for our storage needs. Upon completing these tasks, we continue to face certain issues, which could be highly familiar to students who utilize ClickHouse. The primary concern revolves around performance, specifically the challenges that arise due to resource competition and its impact on overall system efficiency. The reason we use ClickHouse is to store and process a wide range of data. We utilize it for various tasks, such as ETL processes and generating reports. However, there are instances where we encounter challenges. For example, when the management team requires an urgent report for a board meeting, running a resource-intensive ETL task simultaneously can lead to frustration. In such scenarios, the data may not be readily available, causing significant delays and frustration. It is crucial to carefully manage the timing of tasks to ensure smooth operations and avoid unnecessary stress, right? This might be a very common issue. So I see now some new types of this data warehouse, or called asterisk, 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 asterisk database. Some of them have this functionality, which means it will have a replicated cluster to serve some isolated services, some special workloads. Then the second problem is, obviously, we were unable to switch to another product that appears to have this capability, correct? The second issue is that it will continue to exist. Hardware failures resulting in downtime can be extremely challenging for a company to accept in the long term. It necessitates the constant availability of accurate and reliable data, as the ability to access good data when needed is crucial for decision-making and overall operations. That place. That location, thus we took into consideration pondering the most effective way to implement a solution to this problem, taking into account the existing resources and knowledge we have at our disposal. Well, with this kind of master-slave architecture idea, it's also a very straightforward idea. We had already been running it on file system, FS, at that time. We know that FS can have many mount points mounted in different places. So with a direct idea, I just mounted it on another machine and ran it on that machine. Could this be enough with COS? So we really did such a trial, just directly mounting it in another place as well. So this is the file system, and we are running ClickHouse on top of it in the same place where the FS file system is located and operational. Then it has some, what issues? That is to say, with ClickOut, the first thing is that it prevents you from running like this. It goes through a file lock, requiring a copy where only one instance can run on it, which is easily solved by modifying its source code, changing the lock in that place. The second issue is that even if it's read-only, when you apply it, it's still read-only. It will still have some state, for example. When querying, it writes to cache, which is not very secure. Of course, theoretically, we can handle it. And the third challenge is the original data perception, because we indeed have it running, That is the same data on file system running on multiple test instances, but the part where you write to the instance cannot be perceived by other instances. To make it perceive, you have to restart it, which is not ideal. This lack of perception can lead to potential inconsistencies and security vulnerabilities, not actually functioning. At a later point in time, we ultimately devised this resolution, which turned out to be effective. For friends of FS, it's not difficult to think of at all. So the PowerPoint presentation we're really talking about is very simple because the matter itself is simple. In simple terms, how do we create an example of ClickHouse? It should be said that, accurately speaking, this is not called an example, it's called a branch. Because in reality, it can still be written into, but the way we use it is to treat it as one. In summary, the process of creating a ClickHouse example is straightforward, and we refer to it as a branch for practical purposes. Regarding actual usage, we employ the term
Primary-Replica,
which is not a major concern. Let's revisit these PowerPoint PPT slides. How do we create a slave? It is accomplished by taking a snapshot from the main data directory of clicks, using the Joseph command to generate a snapshot directory specifically for that purpose. This allows us to establish a slave and ensure synchronization with the master. The creation of such a snapshot directory is an important step in the process. And then basically you just need to run an additional instance of ClickHouse server on that directory. What we have written here is the procedure to productize some of these things. When you truly need to get it up and running, you need to handle these things. Before running it, you need to shut down some of its stateful consuming other data sources, which implies for us it means shutting down its Kafka messaging system and any other dependent components. Terminate the consumer queue to avoid competition with the main instance for Kafka data and ensure smooth operation. Then you simply execute the ClickHouse server. Once it is operational for our purposes, we additionally insert some metadata. The metadata provides information to visitors about this ClickHouse replica, such as its creation time and so on. Simultaneously, we must delete the mutations within it because these mutations are meaningless when running on this replica, and removing them slightly enhances performance. When you observe that and inquire, it signifies how do you update it, correct? That snapshot, it solely maintains the state it had at the moment it was created. So we do not update it. Our approach is to recreate a replica instance and then substitute it. This process is also highly intuitive, as each replica instance actually comprises of 2 replications. This method ensures that the updated state is accurately reflected in the new replica instance. There is a proxy in front which will point to a specific ClickHouse replica. Then, at regular intervals, or when a certain condition is met, we will redirect the requests accordingly. Therefore, our strategy involves creating an additional replica and configuring the proxy to direct traffic to this newly created instance. By doing so, we can update the replica without causing any downtime. Our minimum interval for updates is every 10 minutes, although we typically perform updates on an hourly basis. This frequency is considered sufficient for our specific situation. Would you agree that this approach adequately meets our needs and ensures the smooth operation of our system? So what? This is what I mean. After establishing the
Primary-Replica,
ClickHouse configuration, we have been operational for more than a year at present, and the outcomes are extremely satisfactory. Results were good, meaning that in the past year, our system had no downtime, and we replicated data over 20,000 times, exceeding 20,000 times. Operation, and then there was not a single failure, so this replication is quite reliable. And its overall performance has improved. The main reason for the improvement is because of this workload isolation. Just say, now I have a replica specifically for serving reports, so of course it won't be. What's this called? The ETL task has an impact Of course, part of it is because the replica data doesn't change, so it has better cache locality. After we've done all this, the overall availability of the report has increased from below 95% to as high as 99% without any application level optimizations. Additionally, this architecture provides us with, let's call it the flexibility on ski scalability, which makes it very easy to, if I need to, I can easily set up a replica to serve something. And then afterwards, once it's done with its job, I can just get rid of it, right? Of course, there's an interesting thing here, which is that there is a friend who is Chinese, and he created this thing called CHDB, which is a Python library. He turned ClickHouse into a Python library, and this Python library, when combined with FS, can achieve complete serverless functionality. ClickHouse, this is a very imaginative one. If the product is made. Then, on top of this, our next steps mainly involve a few key points. The first one is to create a better control interface for automating its lifecycle management and creation, as well as its cache management. The second thing is that when we run this architecture, we found that the main bottleneck is on the file system. To address this, we are planning to optimize the file system performance by implementing various strategies such as caching mechanisms and efficient data retrieval techniques. When comparing this to running on a local hard drive, there is a higher probability of experiencing crashes, which is not a significant problem for us, as it is usually fine in most cases. And then you can synchronize the data with another copy, which is originally something you need to consider in your pipeline. But it is indeed an issue as we conceptually understand why it is likely to happen. In simple terms, because of the inherent risks associated with local storage. Input-output system calls on the file system take more time than on local hard drives. So this might result in some problems in between, leading to some irregularities. These irregularities spread to specific areas, resulting in the crash of this system. However, we have not completely resolved it yet. The third one is ready to proceed. Well, optimizing its write performance, this is mainly in two aspects. One is from the application perspective. Now, because the support for open formats such as Packet is already very good, based on the results of our testing, we have found that the performance of querying certain data on Pocket compared to querying it locally for emergencies can be similar. So this holds true for a large part of it and is an important consideration to keep in mind. For the debt, we have the option to write it into the FS file system outside of the cost, enabling parallel writing in a traditional manner. Hence, there is no scalability issue with this writing approach. Naturally, there are additional complexities to consider, such as determining if we can write this click table into Click. It is worth noting that there have been instances where this has been successfully accomplished in various locations. And finally, by somehow mounting it onto the credit card server, that is the application layer approach. Another approach is to really push the students on how to optimize its write performance in this particular scenario, right? Okay, so in this context, it signifies that we discuss the reasons why we utilize FS. The primary rationale is straightforward. At that particular moment, FS was essentially the sole option to operate on this object storage, which is a POSIX file system. This choice was made due to the potential limitations of other alternatives, as they might not have been compatible with running ClickHouse. And then the second reason is that it is a it has an infinitely more important effortless scalability. That is to say, when we use it, we basically don't have to worry about capacity issues. It is effective, don't have to worry about its capacity issues. The third one is that its total cost of ownership is much lower. We have a little bit more application in the back. The main consideration is cost. The fourth one, it has a very imaginative snapshot feature. This feature, well, I specifically considered this issue here, which is about bringing us this gate branch. That is, this gate branch, well, I think bring the mindset model to the level of the file system. And then it was very well implemented. When you combine two different levels of things together and implement them well, it brings some very imaginative solutions that can solve what you originally needed in a very different level. Problems that require a lot of effort to solve, like the issue we mentioned earlier about the architecture. If you work on a different level, it's obviously a very, very big project. Finally, personally, as an FS user, I really like Joseph FS as a product. It has an elegant design, good developer experience. It really, when you use it, it makes your daily life simpler. Instead of possessing numerous products or frameworks that render your everyday existence more challenging, correct? All right, so ultimately, on the final page, we come across some additional scenarios. Let me briefly mention them. The first one revolves around the cost of credit. Since we have access to the file system, we utilize its capability to access shared storage for data exchange. There are some very interesting scenarios, as I mentioned earlier. We can explore various possibilities and outcomes based on this access to shared storage. Simultaneously, FS is mounted on Jupyter Hub, so certain data science tasks will generate data and store it in a directory. Subsequently, when creating queries or reports, analysts can utilize this data directly to execute combined queries involving all the tables in ClickHouse. This methodology is remarkably sophisticated within the entire workflow. Naturally, numerous engineers may believe that writing this data into ClickHouse is also straightforward, but it gradually builds up over time. Every day, if you don't have to do this thing, it means that the mental burden will be much lighter. The second one is our machine learning pipeline, because all the machine learning pipelines, including those training models and other things, can be stored on this Joseph FS. Then you have a simple way to manage this work. For instance, I can return that job, and when I return it, we primarily use notebooks for management purposes. This allows us to efficiently handle the tasks involved in our machine learning pipeline and ensure smooth workflow throughout the process. The thing about machine learning, so we can, during training, the output of the notebook is stored in a location that I can conveniently access from Jupyter Hub. This pipeline is well established. Lastly, we execute Kafka on the file system to store items that are infrequently accessed but require permanent storage. There are certainly numerous things that you wish to store permanently because they constitute your data assets. You infrequently visit him. There are certain locations where Kafka is utilized for this type of thing. We simply performed it. How did we accomplish it? When compared to the products corresponding to what we used previously, it should be approximately 100 times more cost-effective, indicating that it has transformed from money we cannot disregard to money we can disregard. We conducted some performance tests, but unfortunately, I do not have access to the data today. The decrease in performance on a single machine is quite noticeable, but it is within acceptable limits and does not pose a significant issue. Well, it can still be horizontally scaled. What I mean is, when you add nodes, it can basically scale linearly, so its scalability in terms of throughput is not a problem. However, its latency is indeed larger than local ones, and there may be some instability issues, so it may not be a good choice for real-time stream processing. That is all for my presentation. Thank you for your time.